Good morning, class. I'm here to bring you another installment in the Geniverse tutorials that I've been rolling out to you. Today we're going to try to get through Case 8 and Case 9. Before we do, I just wanted to remind you, last week on Thursday, we were assigned a Punnett Square practice problem page. This is one of the assignments that I'll be tracking for participation in our continuous learning model. I also had a really good question about the tracking in the Geniverse because it is somewhat confusing here. Like if you look at your page, it says completed with this big filled out orange bar, but we know, even for those of us who have completed the cases that we've been assigned so far, that we're not done. We've still got 2.5 more levels. So to be clear, the information is tracked in a different way through this spreadsheet that I have access to, and I can very clearly see here what people have done. So I know that a lot of you have completed this. 35 of us have logged in and done some work on here, which is incredible. I hope that we can get the other few students we need to engage with us and learn with us too. And then we've got some students here who need to just tighten things up a bit and catch up. So for these students, you should be done with Case 9 by the end of the week here. And then the second tab allows me to look at your journal entries. So I am reading those and keeping track of those for participation. So please do continue to write those journal entries. I can see them, I can read them, and I can also tell if you have not been writing these journal entries. All right, so without further ado here, let's jump into the Geniverse. Now we're going to want to go to our case log today. We are working in the apprentice level, and we should have through Case 7 completed, and we should be ready for Case 8. So let's jump into the playground here. All right, so in the playground today, we are going to be looking at a tale of 3 tails. We're supposed to figure out the alleles needed for each type of tail. As easy as 1, 2, 3 tails. So the big difference here is that this trait has 3 different phenotypes. It has a short tail phenotype where it's got this little curled up tail here. It's got a kinked tail phenotype where it's kind of zigzaggy. And then it's got a long tail phenotype where it's nice and straight. So we need to figure out what the dominant alleles are, what the recessive alleles are. The curveball that they've thrown us here is that there's 3. So the way to do this is to pair them up with the other alleles and see what the phenotype is. So long tail, kinked tail. It looks like that still produces the phenotype long tail. Long tail, short tail produces the phenotype long tail. So that means that long tail is dominant to both of these, as I'm sure you were thinking. So let's take a look at the other trait. Let's take a look at short tail. So short tail obviously produces a short tail. Short tail, kinked tail. Okay, that produces a kinked tail phenotype. And then short tail, long tail. Okay, so that produces the long tail phenotype. So it looks like short tail is recessive to both of these traits. The only way you can have a short tail is if you have both alleles for short tails. All right, so that just leaves the kinked tail. We already know that it's dominant to short tail. I guess we already know that it's recessive to long tail as well because we already did that combination. Okay, so let me get some notes taken here so that we can help make sense of these three alleles and the way that they interact. Okay, so we know that long is the most dominant trait, and then kinked and then short. So dominance increases as we move up this list. Let's also assign these different phenotypes letters for their alleles. Since we have three here, our system of capital and lowercase letters kind of breaks down here. So we're going to use capital L for long. We'll just use K for kinked and S for short. Okay, so with those notes, I think we can move on. We are ready for our first challenge. So find the right parents and the right gametes to match each target. So we're given mothers to breed, fathers to breed, and target offspring to create. Before we start looking at the mother and father's gametes, we should take a look at what sort of genotypes we are trying to get with these three drakes. Now I'm going to help you do one of them, and then I'm going to leave the other two up to you. These are not random, so you will have the same three drakes you see in this video today. So it looks like the first one is female. That's going to be important here. We do need to pay attention to what the sex chromosomes are. So if you recall here, just like in humans, these drakes have X and Y sex chromosomes. The females are XX. The males, identified by this throat pouch thing, they are XY. And then we've got a separate set of alleles that we'll need to pay attention to for the trait. So this first one has this nice big long tail. We know that that is dominant to everything. So this means that it has the largest possible number of genotypes because it can have any of these three genotypes and still have that nice long tail. Now the short tail, that's the second one where it's kind of curled up there. That only has one possible genotype because the short tail trait is recessive to all of these other alleles. So the only way in which we could get that is with short. And then the kinked tail, that is let's see. It's recessive to long tail, but dominant to short. So that means there'd be two possible phenotypes for a kinked tail drake. It could be kinked, or kinked short. So I think I'll help you make this guy. and then you'll do these other two on your own. So let's go back to the Geniverse here. Let's see if we can do this. We'll need to see what these parents have for their alleles. Okay, so there's the chromosome with the trait we're looking for. This one's long tail, long tail. So, and if we use this mother and inherit either of these alleles, the only thing this mother can give to her offspring is long tail. That's not going to work because we can't make a king-tail drake if it has a long tail allele in its genotype. So that mother's not going to work. Luckily, that didn't use up one of my moves. Okay, that must mean that this mother has the allele. Otherwise, it would be impossible. Let's take a look at the father. Oh, I guess we need to see if she has kinked. Long tail, no, we're not going to want that one. Short tail, okay. We can work with that because kinked is dominant to short tail. So if dad has an allele for a kinked tail, we're in business. Oh, shoot. Dad's long tail, short tail. So we're going to have to use this other father. Didn't use up a move. Okay, now we're also looking for a male drake. So we could have to run meiosis again because kinked tail will need to be paired with a Y chromosome. And yeah, kinked tail's over here with the X chromosome. So I'm going to have to retry meiosis with dad again. Okay. Shoot. Hopefully this time we'll get it. So if you're not following the problem here, the problem is that this drake is XY for sex chromosomes, but since it can't inherit kinked tail from its mother, it has to inherit kinked tail from its father. So we need, I think this is it. Oh, shoot. No. Again. So the issue here is that the kinked tail trait is not getting paired up with the Y chromosome. It's getting paired up with the X chromosome, and I think it did it again. So it looks like the kinked tail trait is on the purple one. So we want to run this until the purple chromosome ends up with the Y. Did we get it this time? Please? No? This is getting a little ridiculous. Oh, here we go. All the purple chromosomes went into the gametes with the Y. Yes, got it. See, kinked tail, Y chromosome, that's what we've been looking for. So we'll hit play, fertilization will undergo. I'm pretty confident that I've created the right drake. After we match this up, you'll need to create the other two drakes and then head back to Google Classroom for the next tutorial. Thanks for watching.